Hello, everyone, and welcome to our latest edition of the Lightning Interview Series. As always, we want to make these sessions interesting and interactive, so please do introduce yourself on our chat channel and tell us where you're joining from and what you do. And of course, please feel free to add your own questions to this conversation. Now, our guest today is the highly regarded machine learning expert, speaker, and author, Parul Pandey. And we're going to discuss machine learning for high-risk applications and, of course, the risk-reward trade-off. So before we get to the highlight of our day, just want to go over some upcoming events. Now that we're into what is about to be fall, things are getting a little busier. We do have quite a few free webinars and sessions coming up. We got another free webinar on September 27th on unlocking the power of knowledge graphs. A lot actually going on in that sector, especially with LLMs as well. And then we'll have the ever popular Lawrence Maroney from Google to talk about this future of software development and AI. And that'll be followed in October by a webinar I'm actually looking forward to quite a bit, because I used to do time series forecasting, was kind of my introduction to data science and machine learning. So in that webinar, they'll be looking at time series methods such as autoregressive integrated moving averages and the profit procedure, which you may know, pretty well known. However, how does that compare to, say, advanced feature engineering for time series? So I think that's going to be very interesting, and that will be followed by another lightning interview in October on the promise of no code and low code, and the hope there that will make AI more inclusive. And of course, we do have ODSC West. As I mentioned in the prior weeks, it is back in the heart of Silicon Valley, or the heart of the AI boom, as we like to call it. It is virtual, both virtual and in person. Just a preview here, I do believe that the team is announcing a 2-for-1 offer next week for a few short days. So go check that out if you have a chance. We're going to be doing lots of new things there. We have a multimodal hackathon, which is actually free to join. That'll be going on, I believe, on the Tuesday of the event. We have a new series of lightning talks, and something I just was talking to an organizer about it. We're going to be doing kamikaze lightning talks, which should be fun. So that's going to be a treat for those of you joining us. But we still have discounted passes available. There's also expo passes as well if you're looking for a free pass, and then of course we have it going on virtually as well. So purchase a pass, grab a free pass, whatever suits your needs, and looking forward to joining you there. And all right, so as you know, our discussion for today is the topic of machine learning for high-risk applications and the risk-reward trade-offs. And our guest today is an expert in unraveling the complexities of machine learning and understanding the delicate balance between the promise of machine learning and the perils of unforeseen challenges. So in this episode, we want to delve deep into the risk-reward trade-off and navigate through some interesting use cases and the importance of explainability and the evolution of models and the ethical considerations of that underscore every decision we do when we build machine learning models. So to facilitate that discussion, our guest today is Parul Pandey. And as mentioned, Parul is one of the co-authors of the Machine Learning for High-Risk Applications book, which focuses on responsible implementation of AI. And Parul currently works as a principal data scientist at H2O. And you may know H2O already, but that's well known for being one of the top open source machine learning platforms with a mission to democratize AI. And prior to this, Parul worked at as a machine learning engineer at another company we love, which I'm sure you use, which is Weights and Biases. Lucas and team, I believe, are speaking at West as well. And Parul is also a grandmaster in the notebooks category and was named one of LinkedIn's top voices in software development category. And you may know her from the many articles she's written focused on data science and software development in various publications. And she's also well known for giving back to the community through our speaking sessions and mentoring and workshops on responsible AI, and will actually be an ODS speaker in West this year. Parul, welcome to the show.
Thank you so much, Seamus. Very excited to be here, and looking forward to have a wonderful chat and
Yeah, as
conversation
are we.
around.
And yeah, Parul, as I mentioned, you co-authored the book Machine Learning for High-Risk Applications, which I did finally manage to get through all of it. And I have to say that is an extremely detailed book, but it's not a criticism because I found it was a fantastic breadth and depth other books I've read on responsible AI, because we run a AI safety, responsible AI track at West, have at least for the last couple of years. So I've read quite extensively. So I've never seen a book that looks in so much detail with so many takeaways, especially practical takeaways. So congratulations to you and the authors for writing a fantastic book. We'll share a link to that as well, so you guys can check it out for yourself. So I would highly recommend it. If you care about responsible AI and machine learning safety, which you should, I think this is a must read. But more about that later. First, I want to know about what inspired you to pursue your career in machine learning and eventually to co-author this book.
I think it's a story for a lot of people. I did graduate as an electrical engineer, and so I actually went on to work for a public electricity distribution company. And as it would happen, I was actually working with a lot of data over there. So you could typically say I was a data analyst. And then the gradual, you could say, the path from there was machine learning, because it was at the time when it wasn't called machine learning or data analysis. We were just crunching a lot of numbers, and we were using things like SQL and R and stuff like that. But then from there on, after working there, I came to H2O, and fortunately, I was surrounded by such a group of people, and I was seeing the way people were working here. And as you already mentioned, that H2O has been a pioneer in open source data science and machine learning for quite some time. And from there, it was just a natural and gradual shift towards machine learning and deep learning. And again, I think the seeds for thinking of like using AI in a responsible way was actually sown in H2O, because at H2O, from that time, we were taking responsible AI very seriously. And one of my co-authors was at H2O at that time. So he's no more at H2O now. But so the idea floated, three of us came together, worked for about 1.5 years from three different time zones, and we didn't make it
Wow.
happen.
No. Yeah, and I can see why it took so long, because again, like when I said, the depth and breadth, fascinating. I really did, having been a chief security officer in various roles and consulting roles in the past, and dealing with machine learning safety, I did appreciate the attention to standards and the research that went into that book. So it was absolutely very well done, and I think very important contribution to the knowledge base we have around this topic. So one of the first things I liked about this book was, like, in chapter one, or I think it was chapter one, you had a use case around Zillow's iBuying. And for those of you who don't know, Zillow is a very well-known company here in the US, around the world. And you can basically look up how much is my neighbor's house worth, allows you to be curious and stuff like that. And they came up with something called iBuying, which allows they would actually allow you to offer your house to them for sale, and they would use machine learning for models. So having done a lot of financial consulting myself, I was very skeptical of that. But anyway, Parul, I would love to explain that use case in the context of today's topic, because I think it's a fantastic use case that you guys started with.
Yeah, Zillow's iBuying case is a classic case when now today we talk about how not to use machine learning. Even though, of course, I always say I have nothing against those people. I have some great friends working at Zillow, and they have the best of engineers. But I don't know, a lot of things just didn't go well. So for the ones who are not aware of it, in 2018, if I can recall correctly, Zillow started something called Zillow Offers, where they would buy houses at a lower price, and then they would flip it for a profit. And the way they were coming out with with the price was through their algorithm called Estimate. And so initially they were like treading pretty carefully because they had, you could say, domain experts and real estate agents. They would initially validate prices with them, which is fine, and which should be done because real estate agents, I believe, are the ones who know a lot about the area. They know what is going to happen in 5 years or what's going to happen next year. So things are going pretty well. But then what happened was uh, they soon phased out the human experts because humans cannot keep up with algorithms. So basically, they were on a buying spree, and humans would take some time to come with the results. And they're going so fast that it said that they acquired almost about 10,000 homes in a single quarter. Now, when you buy homes, they were buying it because they wanted to sell it, but then selling a home is very different from selling furniture. It takes time. You've got to renovate your houses. You have to uh, you have to have a staff for maintenance and stuff like that. And and also there was difficulty in maintaining the mortgages. And then the worst of it, the pandemic struck. So there were no staff people to renovate it. And because of all of this, because they had bought so many houses, they started having a large inventory of homes. And now to get rid of that inventory, they had to sell it under at a loss. And they had to write down an inventory of about $500 million. Now that's for the company. The thing that I look at it is how it affected, and this is like a classic AI incident. And how can you convert this AI incident into money? Is that people lost jobs. So at the end of it, what they did was they fired a lot of staff, about 2,000 employees. They lost their livelihood, and it was during the time of pandemic when things were actually very hard for people. Um, so what I feel is if I were to put it into financial transactions, it's an AI incident for about $30 billion. And now, if before they went into this iBuying stuff, if they had realized that if this thing goes wrong, it's going to cost them this much of money, maybe they wouldn't have jumped or gone so fast and taken so many decisions. So it's very important. So when you put out your products out there and you're using AI, machine learning, or automating stuff, keep in mind what is going to be the consequences. So here it was losses. People lost their jobs. The share price went down, and of course their name as well. So this is a big learning for other companies who are in real estate and who are in other businesses also, which involves AI, machine learning, and algorithms.
Yeah, no, absolutely, and I'll echo that because I knew some of the machine learning engineers there who had spoken at ODSC, and I thought it was it was quite sad because highly talented team, but the top level strategy, as you mentioned in your book, was flawed because they did away with the kind of the human loop factor because they had the real estate agents checking the models and then they dispensed and
Yes.
they made it fully automated. So that was unfortunate because the concept was sound, the engineering was sound, the whole system was sound, but you can see that sometimes without understanding the responsible and the risk, as essentially as you said, they didn't do a very good risk evaluation around this, and like we always talk in software and AI about de-risking, right? So that is definitely a very important lesson. Now, you speak a lot about the importance of explainability. We've been explaining explainability for the last 5 years. So I'm sure many of us on this call know that. Maybe we can go into that a little bit. But what I liked about your the book and some of the articles you've written is looking at explainable models versus post hoc. And post hoc is maybe not something that people are familiar with. So can you delve into explain what we mean by explainability versus post hoc, and then delve into the trade-offs between using inherently explainable models like linear models versus relying on post hoc explanation techniques?
Yeah, so this is a topic like we've dedicated about 2 chapters, 2 full big chapters on this, and that essentially comes out from our experience in the industry of using these models and then talking to people in regulated industries also. So for me, the way I like to define explainability is so if a model is explainable, you can sort of see through it. Now you could call it transparent, but then we also say that having transparency doesn't mean you can trust the model, because there's a line in the book which I really like it. It's like we can trust things we don't understand, and we understand things that we don't trust. So I read a lot of blog posts and I see that, people write, okay, so this is a model, I've created a model, and now this is the technique I'm using to explain it, and hence now I can trust the model. Uh, I think explainability doesn't make a model trustworthy. It's like when you explain the model, then you understand how the model is making decisions, and then you decide whether that model is good or bad. If it's a good model, then you can definitely trust the predictions. But if it's a bad model, then you should go and sort of change things and make sure like why it's taking wrong decisions. So that way explainability is very important to understand like what's going under the hood, whether the model is picking up on actual correlations and not just noise, or what we call spurious correlations. Uh, because we've seen a lot of examples where we just go and we see, the performance is great, the accuracy is great, but then we see the features on which those predictions are made, they're just crazy. So that's why I think this is important. Now, there comes this tension between these two schools of inherently interpretable models and post hoc techniques. So just for the ones who are not like aware, so inherently interpretable models are like the models which are themselves explainable. So don't need any external techniques to explain them. The results from there, for example, linear models, you can look at the coefficients and then you will know like which feature the model considers as important. And there are other techniques like post hoc techniques, which you only apply to a model after it has been trained. So these are model agnostic. It doesn't matter which model you have, you treat the model as a black box, and you simply need the predictions, and then you can apply those techniques. Now, for a lot of time, there's a very famous graph that I see, which says that if a model is more complex, then it's less accurate, and if your model is more accurate, then there's a trade-off between complexity and accuracy. So if you want accuracy, then you'll have to take a complex model. But the thing is, if you look into the industry and you look at especially banks have been highly regulated for a long, long time. And they are using inherently interpretable models. And these models, like some of the ones which I'm going to mention now, they are as good as your, let's say, XGBoost or Light GPM. So they fall under a category of GAMs, generalized additive models. Then there are another category of models called explainable boosting machines. So these models are interpretable. They're very accurate, and they can be used in high risk applications. So the whole tension between explainability and accuracy and this trade-off. In fact, there's a great paper by Cynthia Rudin who said that stop explaining black box high risk applications with post hoc techniques, because a lot of people, they say that post hoc techniques are not reliable, because I think it's a very valid point. So post hoc techniques are used after a model is trained. So if you train a nonsense model, the explanations will also be nonsense. So that's one of them. And plus those post hoc techniques they're not actual, you could say, they're not actually telling you what is going under the hood. So sometimes they're not even faithful. So there's a lot of points that people have against it. So what we found while we were working on a book was, it's always good to pair your the output from your inherently explainable model with post hoc explanation. So if you pair both of them and you see that whether both the techniques are giving you the same answer, then you can be confident, that you've created a good model, and then you can deploy it. I just hope I've not confused the whole scenario.
No, I think that was really good explanation, Parul. And we do have a question from, I believe the name is Rash. It might just be username, but good question. So as you can see on the screen there, what makes explainable models risky? Isn't domain knowledge key to making efficient models? I guess the Zillow one is a good case in point. Yeah, so if you don't mind addressing that problem, like how a newbie data scientist can make sense of their models.
Yeah, so I think the answer is in the question itself. I think model itself is not risky or it's not safe. When we talk about applications or when we deploy stuff, it's not as easy. You just cannot rely on models. It's a whole process. It starts from you know, these are organizational processes are involved, cultural processes are involved, and then you use a model to make predictions, and then there are systems after you deploy the model also. So modeling is just one part of this whole pipeline. Like you said, domain knowledge is the key. Yes, domain knowledge is a very important key to make efficient models. And if there's a newbie data scientist, make sense of their models. So I think this is something very important. Firstly, when you enter the industry or you enter a company and where they're in the process of creating machine learning models and they're deploying it and people are using it, it's very important to see if they have some process. An important thing is there should be a process in the company that is being followed. If you're new, then you should not directly have access to put models into production. Uh, there has to be a check at every stage. I mean, anything can go wrong. And let's say if you're in a healthcare industry and you have the rights to just deploy models, and so that's going to be risky, right? So as new, we have to learn what is in the company, what is the process, how do they take place, and modeling is a very small part of it. Uh, and if you specifically talk about modeling, then these techniques, the ones that I'm telling you about explainable models and post-hoc techniques, these are way to sort of understand that why your model is making predictions. And then there's no right or wrong. You try the existing models that you have, and you see what is the performance. Then you use more complex models. You see what is the performance. Then you see why the model is making such predictions, and you see whether these make sense to you. For example, I'll just give an example. Let's say you've created a model and it has an AUC of about like 95%. It's a great model. And now you want to see which features the model relied on. And then you see, let's say it's a healthcare model. And then you see, okay, the model is saying that as the age of a person is increasing, the bone density is also increasing. And let's say you have some background in medical science and you see, no, that's not correct, because as we age, the bone density should decrease. But what my model has understood from the data is this. So these are some of the red flags, that you'll have to see case by case.
No, very good point, Parul. And I notice, yeah, especially newbie data scientists, they get confused when I say things like it's really helpful for to understand the domain you want to work as well. I'm applying for jobs in retail, online, at Google, at Meta, at a healthcare company, at a finance company, and that's why I will say it's very important to have a very strong understanding of responsible AI, machine learning, and AI safety, because the techniques and what you need to understand, they run across industry. So definitely, domain experience is important that you study that, but no one expects you to be a deep domain expert, but understanding AI and ML safety is kind of key there. And cool, I want to delve into another question because you mentioned performance as part of that discussion there. So, because one thing is like, okay, getting into the methodology here, we all look at, and you already mentioned some traditional metrics. So traditional metrics versus real world performance. And in your book is also, you also mentioned the limitations of traditional machine learning metrics. So can you give some real world examples where traditional metrics indicated success, but the model faced issues when deployed, especially in context of risk?
Yeah, so I think we have few case studies in the book also, and I think there's some very well-known examples. And because we are in this era where LLMs are everywhere, so there's a classic example of the chatbot. So I think a few people also know about it because it was in a lot of news. So in 2016, Microsoft researchers they launched a chatbot and they named it as Tay. and with very good intentions. What they wanted the chatbot was to, they wanted to sort of make it live on Twitter, and they wanted the chatbot to learn from the users' replies. And then it would also indulge and talk with the other users. So it was essentially sort of designed to generate human-like responses, and they just wanted to see how it will learn. So the traditional metric would have been, just a traditional, like how well it is going to reply or how well it is understanding the context and how is it replying. So I think that was what it was researched on, and it was giving great results in research, and then they finally made it live. But the real world is very different from the sandbox environment. So after a few hours, initially it was pretty nice. It was saying, hello, I like humans and this and that. But then suddenly what people started doing on Twitter was they started, feeding it offensive tweets. And because it was learning from users, after some time, that chatbot also started you could say, outputting all the offensive and weird tweets. And the situation went so bad that they had to shut down the chatbot within 24 hours of its deployment. Um, and so, of course, the researchers never anticipated that such a thing is going to happen, because when you work in your lab, and of course, there are researchers from Microsoft, they're supposed to be great engineers who are good at their jobs. So they've trained it on some data. The data would be clean. They never thought that this is going to get some sort of data, so you could say adversarial inputs in real world, and so they deployed it, and it was bad. I remember it came in a lot of news. Even though the LLMs today, I think they have some mechanisms in hand, so that the chatbot says that I'm an AI language model, I don't have access to this and all the stuff. But that was a clear example of how things can go bad in real world.
No, absolutely. And since then, because it was with the pets and pensions, but the whole study of adversarial machine learning came out of use cases like that. And again, something that we all need to hack our machine learning models and give them adversarial examples and understand where the inputs are coming from that. So a hard learned lesson, but I think the industry, as you can see with these LLMs and the efforts that companies like Anthropic and OpenAI and others are paying to those models is because of those prior use cases. So it was not for naught, I guess you would say. But okay, so now we know what can happen. Now we know the issues. So how are we going to find these? So it's an old-fashioned term, debugging techniques, but we still need to debug our AI models, look for those adversarial examples. So what are some of your favorite techniques when you're working at H2O or weights and bias for like debugging these machine lessons, especially the more complex systems like deep learning systems, transform systems like LLMs and stuff like that?
So the interesting part about, I think, model debugging is a lot of the approaches that we use for traditional machine learning sort of fits into this generative AI space also, with a little bit of elbow greasing. So for example, I think one of the testing which is borrowed from software testing is the chaos testing. It's like just test your models under chaotic environments and see does it break, or what happens. On similar thing is the stress testing, and stress testing is a very common technique which is used by federal banks, and they have to go through this activity every year, where they simulate data of unforeseen circumstances. So for instance, let's say for recession, so they'll simulate data of recession, and they're going to test their models on that data and see if their models are able to sustain it. And so they create models in a way on data. So instead of just testing models on validation data sets, they create data themselves and test it. And I think that's a very good example. We remember when the COVID struck, a lot of models, their predictions just went wrong, especially in the demand sensing area, because nobody had predicted that such a thing would happen and we'll be in lockdown and demand would suddenly drop. So for such unforeseen circumstances, I think stress testing your model is essential, I would say. Another very common technique I think we've also used in our book for an image classification model is label shuffling, is just randomly shuffle your labels, and then you retrain the model. And then you look at the features which now the model considers as important. And that means those features are not important because you've essentially just changed the whole output of your data. And then you just get rid of them, and then you retrain your model, and then you check it again. And so these are like 2 or 3 techniques which we've also applied, and which I have seen like people do it in industry, and they've really benefited from it. And other than that, if you talk about LLMs, I think red teaming, then testing them on adversarial inputs, hacking your own models, testing on weird inputs, and forcing your models to say something that it doesn't want to, and then see where it breaks. I think these are some of the common techniques which are very easy to use, and I think it should be used more often.
Yeah, no, 100% agree, because SHAP and Lime are free open source tools people can use for this, but they've been around a while, so some of the newer ones, I know they're being adapted. And it also kind of astounds me as well, because when we're using tools like LangChain and other ones like that, it's like the very old tried and true is like giving like good logging, good monitoring, and having tools for looking at your logs and monitoring go quite far as you're feeding in these adversarial examples as well. So some old-fashioned techniques for software development we find are often overlooked, apart from looking at your traditional ensemble learning and other efforts like that. So another question I have, which may sound like an oxymoron, but safety and performance trade-offs, right? You may say, well, there should be no trade-off with safety and performance. It's safety first. But in the real world, you sometimes have to make those safety versus performance trade-offs. So are there situations where there's a direct trade-off between model safety and performance? And if so, like, how do organizations navigate what can be a tricky decision there?
Yeah, so I think if you know that you're working on a use case which is going to be sensitive in nature and which is going to affect humans, I mean, then obviously I think the priority should be given to safety. Let's say if you have a system which recommends movies as opposed to something which recommends insurance or suggests whether a person should get a loan or not. So in those cases, I think the emphasis should be more on safety. And there's a very classic example, and I think sometimes things are not such straightforward, and this just ties back to what our conversation was on metrics. So there's this case of Google Photos. So Google Photos would, I think it's about 3 or 4 years back. So I think in 2015, I suppose the case was. So Google Photos was using machine learning to tag or categorize the photographs, and then they would categorize. I remember in our app, like this is table, and this is whatever John, and this is a fruit, and something like that. So here, if you see, the metric was to categorize how many correct categorization it does. And so if it does 9 correctly, classifies 9 out of 10, or tags correctly, so it is 90% model is going great. And then a problem occurred was that it had labeled a certain race of people as an animal, which created a lot of, obviously this is not something that you expect out of a company like Google. And during that incident, there's something that came to my mind was you cannot treat everything on the same plate. So let's say if you make a mistake of, let's say, in classifying an object, let's say you classify a cat as a dog, that doesn't have those ramifications as classifying a human as an animal. So even if your you have a machine learning algorithm and it's 90% accurate, but it is inaccurate in classifying humans, that's bad. Then if you have, let's say, a 80% uh, a model which is 8 times correct out of 10 times, but it doesn't make mistakes in classifying humans. All it makes mistakes is in classifying, let's say, objects. So I think the metrics also, the way we define, it should be specific to the task. We should not just go with universal metrics. And that comes when we talk about sensitive use cases. There we should look like we cannot have a generalized metric for everything. You cannot, you have to compare, apples to apples. You can't compare apples to oranges. So for me, I think that's a big criteria. And that's where I think a lot of companies should invest and promote. Like, don't just go for blindly for metrics, universal metrics. It has to be based on your use case. And then if we come back to the question of trade-offs or how you actually ensure during safety. So I think every time you ship a AI product out in the market, like 3 important questions that you can ask yourself is, what is the financial risk with this application if it goes wrong? How many people will get affected? How many, let's say, minority groups will get affected? Because sometimes it happens that it's only the minority group or the disadvantaged group which is at a loss. So if these things are also kept in mind while designing the product, right from the design phase, we are going to get at least little robust, you could say, products at the end.
Yeah, and just following up on that, because I really liked about your book, as I mentioned earlier, was because when I used to do consulting around AI and machine learning, uh, it kind of surprised me how reluctant companies were to look at standards, because how do we maintain? We have our internal standards, company-wide standards, but there is a lot of standards around software, and those standards are also around machine learning. So in your book, you mentioned ISO standards, the NIST, AI, RMF, I think it was RMF standard, among others. So how would you design effective safety protocols in the context of machine learning, and what are key components when using some of these standards? Like, what do these standards speak to, I guess? Where can standards help us?
So a lot of people today, they say that like AI or machine learning, they don't have regulations, they don't have standards, but there are standards which are being built up. And for example, this very year, the NIST, it came out with the AI framework, which is AI RMF. And I think they have a common, and the EU AI Act. So all of them are now. It's a time, I think everything is being built up, and now the NIST is working on generative AI, also regulatory framework, which so I'm also volunteer for that. And but these are all voluntary. These are not. You could say these are not rules. These are not guidelines mandated by the government. These are voluntary. But having said that, they're voluntary, it's a very good time for companies to go and adopt them. And that way, they at least, if they don't have a standard of their own, they can take help from these standards, and they can sort of work towards imbibing those standards into their own culture. For example, some very common things that they talk about is risk assessment. So identify the risks, that associate with deployment of your product, and risk tiering. So divide your risks into like high risk, low risk, medium risk. Based on that, you can divert your funds over there. Um, Data management, have ensure that the quality of data that you use is good. I mean, these are all, I think, the ones things that we already know, but sometimes we tend to overlook them because there's not a definite standard, unlike, like, let's say, GDPR or stuff like that. So company easily say, okay, there is no regulation on us. So unless and until there's a regulation, we are not going to follow anything. But if they comply with this, not only will they abide by the laws, I think they'll end up creating a product which is going to be useful and not harm the people.
Yeah, very well said, Parul. So getting into some modeling techniques, your book goes into a lot of detail around supervised learning and unsupervised learning and other techniques. But we know like supervised learning has been around for quite a while. And we know that learns from repeating patterns from past recorded data, past captured data, and that often results in certain demographic groups, which you've already kind of mentioned, experience more bias. So, and that's historically it's been older people, individuals with disabilities, immigrants, people of color, women, non-gender conforming individuals, and are more likely to face bias from these machine learning systems due to the nature of supervised learning. Now we're shifting into the a different world here. Supervised learning is still around, but what do you think about the types of learning from deep learning or LLMs that will they mitigate or worsen this bias?
Um, so I think the concept of LLMs and supervised learning, like it's not mutually exclusive. I mean, because even the deep learning models and they still rely on the training data. And one aspect of why bias creeps into the models is because of the bias in the data itself. And unless and until we work also on how we gather the data, how we work on that data, if we get, it's like garbage in and garbage out. So if we still get biased data, no matter how good our models are, they will generate again stuff. They'll spit out stuff which is again racist and which is going to be biased. So it's also, I think, good time to also focus. I know there's a whole wave of data-centric AI, which is also coming to the forefront. It's also time, I think, we should also work towards the way data is labeled, who are labeling the data, the workers behind it, how are they being paid, and all those issues, because that's also something as AI companies and as data scientists, there's a moral responsibility to ensure that the way data is being collected is also done in a responsible way.
Yeah, and following up on that, so you talked earlier about adversarial attacks. Topic has been around a long time. So can you just so people have a better idea here, like can you talk about adversarial attacks on say more traditional machine learning models, the supervised learning ones, just to follow up on that last comment you had versus adversarial attacks directly on deep learning models and LLMs, because you mentioned the Twitter ingestion, garbage in, garbage out, Twitter example on Google. So yeah, I'd love to dive into that a little more because I think that's super important this era of generative AI.
So yeah, I think the adversarial attacks they've been quite for some time, uh, and I think the way they differ from the traditional, you could say the vulnerabilities in machine learning is that if you look at those linear models, most of the vulnerabilities that arise is, because of things like overfitting or let's say poor generalization and stuff like that. But when you talk about deep learning models, they're pretty complex, having millions of layers also, millions and billions of parameters. And I think there things get a little tricky because uh, now the adversarial attacks can be from somebody inside or outside your organization who has some nefarious purposes, and they may want to target specifically so that they could elicit a particular sort of a response from the model, especially if you talk about sensitive scenarios, or the attack would be highly targeted. Maybe it attacks a particular node or a particular layer. And such attacks are difficult to identify. I think that's the main problem also. And another, I think, dangerous aspect of adversarial attacks is it's scalable. I mean, it can be transferred to other deep learning networks. So if you talk about our simpler models, it's more localized. The vulnerability is there. So if it affects a single model, you can take care of it. But when you talk about those adversarial attacks, they can be transferred to other systems also. And as for humans, it's very difficult to detect them. So like we have that classic example of the panda, where a little bit of noise is implicit, like humans cannot differentiate, but the model, it misclassifies it as I think a gorilla, or I don't know, something like that. So that's, I think, a little tricky part of those adversarial attacks. And we also have an example in our book where we've attacked a chest X-ray system. We cannot actually see anything difference in that, but our model misclassifies that pneumonia. So it's an absolutely clean picture, and you attack it, and it classifies it as pneumonia. And when you look at it from a hacker point of view, it's dangerous.
No, great examples. And another thing you mentioned in your book, and you just brought this up, was what I will call it, like move fast and break things. That's very much the startup ethos. Like, we're going to build a startup, we're going to move fast, we're going to break stuff and go in. And that obviously has spilled over to tech, and obviously spilled over to AI, and never more so than when we can move faster now with LLMs and all this stuff. And it's fascinating to me because I was just at a presentation last night, and I'm not sure if I believe these numbers, but it said certain corporations, and again, I don't know the size of corporations, the demographics of the corporations, geolocation, all that stuff, but it said 70% of corporations have banned LLMs, working with LLMs. So you've certain companies that just banned using it outright for now, until they understand it more. And then you've other companies that are releasing something GPT every second day, right? And they're moving fast, and they're trying to break things. They're trying to break traditional models. So what advice do you have for, I'm a machine learning engineer, and my boss comes to me and says, yeah, we're gonna retrain Lambda 2 on our data, and we're going to launch this thing, and we're going to be famous, and we're going to get 100,000 stars in GitHub or whatever. So when you're put in a situation like that, especially as a newbie data scientist or something like that, like to move fast and break things, what advice do you have for AI experts or aspiring AI experts around this issue of move fast, but in the context of what we're going through right now with Gen AI and stuff like that?
So my advice would only be don't move fast, take your time, because by moving fast, you can break more than just code. And the problem now is like machine learning and AI, it's going to touch every aspect of human lives. I mean, I don't think there's any going back. Every application, every gadget you're going to touch, there's going to be some sort of AI, some sort of models working on it. And they're going to be humans interacting with it every way. ChatGPT, for example, there are little kids who are using it to write their essays, and they can ask any sort of question. And if there are no guardrails or nothing, and tomorrow the ChatGPT tells them, how do you go and fight with a person, or how do you bully another child? For them, it's really dangerous because they don't understand the technology. They don't understand that there's not a human on the other side. And these use cases you have to keep in mind, because otherwise, for example, if you look at deepfakes, I always say they have the potential of causing wars. And especially in countries, they can, and worse cloning systems and whatnot there. So I know it's about profit for some companies, but I think it's time that as data scientists and as AI engineers, it's also more a responsibility to ensure that the products that we are creating, if not doing good, they're at least not harming people. Because like we already discussed, the people who are always harmed are the underprivileged ones, the marginalized people. And we don't want it to be like that. And then ultimately, I think the regulations, if they come, then you'll have to pay in dollars. So it won't be good for you, won't be good for your reputation. And otherwise also we have to think very wisely how we use technologies.
Yeah, and that's fantastic, Parul, because the main takeaway from reading your book, having this conversation today, for me, is that we need to understand the risk and reward factor we're doing there, and we have to gain that knowledge ourselves. Because if your boss is coming to you, or your organization is coming to you, and they want to move fast, they want to build these new technologies, it's our jobs as AI experts, as data scientists, to understand the risk and rewards, and to educate, as we like to say in business, manage up, manage sideways, educate our colleagues and our the powers that be of the risk reward there. So, because sometimes we get excited with the technology, and we want to move fast as well. Whether it's resume building, just enjoying your job and all that stuff. But so that's why, again, I found this conversation today absolutely excellent, and I would recommend everyone reads that book, because at some point you're going to be at that situation in your career where there's none of these use cases or examples. There's people sometimes mistake bias in terms of human versus machine bias. Like, these are all unintended consequences. But like all software and technology and AI, you have a responsibility to study and understand those unintended consequences, and a lot of effort needs to go into that. And I think it will do your career very, very well, because that's where people look up to you, and make sure that you're looking out for the company itself and the software you're building, and of course the wider public and the wider audience, to make sure that none of those unintended consequences occur, or at least flagged as well. So again, Parul, this has been a fascinating conversation. Can I ask you the last question? Like, how can people follow your work? What else do you have going on?
Yeah, so I'm pretty much very active on LinkedIn, as well as Twitter. So my name is Parul Pandey there as well. So feel free to sort of get in touch with me, ask me anything about book, AI, or in general. Happy to answer.
Yeah, Parul will be doing actually a session at ODSC West on, guess what, machine learning for high-risk applications and techniques for responsible AI. So Parul, thank you so much again, and thank you for being an ODSC speaker, and look forward to chatting to you again.
Yeah, I had a wonderful time, and thank you so much for having me.
No, it was our pleasure indeed. Okay, everyone. So as mentioned earlier, we have a whole series of lightning interviews coming up over the next months. We'll continue. We'll have a few more we're going to announce yet, but don't forget to check out AI Plus training. Check out ODSC. Grab a pass when you have a chance, and we'll see you next week. Bye for now.